And so you've learned last time that a you are sure that a root is in between two values of x, or is in between values of x, a and b, if f of a times f of b is less than 0. Means to say that the sign of f of a is different from the sign of f of b. Okay, then you are sure that the root r is in between the values a and b. Okay, now that is still true in this method. So if f of x is real and continuous in x, which belongs to the interval from a to b, and f of a and f of b have opposite signs. Opposite signs, meaning one of them is positive, the other one is negative. That is, in other words, no, f of a times f of b is less than 0, or is their product is a negative number because they have opposite signs, right? Then there is at least one root between a and b. Between a and b. Okay. Now, in bisection method, the concept is like this. Say, for example, you have a function f. So a function f whose root r is this. This is the root of the this is the 0 of the function, or the root of the equation. This is the root r. Okay. Now, at x equals a, obviously the value of the function is negative. So this is f of a. It's negative because it's below the x-axis. Now, let's say, for example, this is x equals b. X equals b. Now, the value of the function for that particular value of x is positive, no? Because f of b is above the x-axis. Okay. Now, in bisection method, what you do with this interval from x equals a to x equals b is divide it into two equal parts. Okay. So upon division, you'll be having a number here in between, right in the middle of a and b, which will be an approximate in our iterations. Okay, this is x sub n. So this is now this is now f of x sub n. Okay. Now, you have obtained by dividing the interval from a to b into two equal parts. You will now be having two different intervals with the same length. No, one interval would be this from a to x sub n, and the other interval would be from x sub n to b. Now, one of those two intervals will still contain the root r, right? Okay. Now, to know whether the root r is contained in either of the two new intervals, you will be applying the same concept here. So it's either f of a times f of x sub n is less than 0, right? Or f of a times f of x sub n is greater than 0. Now, if the first case happens, then we can assure, okay, we are now assured that um, the root is contained from A to X sub n. Now, if the second case happens, if this product is a positive number, then it implies that the root is contained in the second interval from X sub n to B. Okay, so the root here, root R is in the interval from A to X sub n. So for this, the root R is in the interval from X sub n. All right, so that's what you do. Now, if you already have obtained that f of a and times f of x sub n is less than 0, then you are sure that the root is here. Then you have to do the same thing. So from here, you divide it into two equal parts again, and then identify whether the root is contained in the first interval or in the second interval until you reach something, a number that is very, very close to the root r. Okay? That's what this method is all about. So since we are just dividing a certain, it's like a line segment from A to B, no? We are dividing it into two parts, two equal parts. So the formula that we'll be using is the formula for getting the midpoint of a line segment. So the midpoint formula is what we are going to use for x sub n is a plus b over 2. Okay? Simple lang yung formula natin. Okay, so this will be our procedure. Okay, step 1, choose A and B. Choose A and B such that f of A times f of B is a negative number. Okay? Now, step 2, use the formula. X sub n equals A plus B over 2 to get the next approximate. Okay? And then the last step would be this decision making. Okay. If f of A times f of x sub n is less than 0, then we know that R is contained from A to x sub n. Therefore, set B equal to x sub n and go back to step 2. Repeat the procedure. Okay? Now, if it happens that f of A times f of x sub n is greater than 0, then we are sure that R is contained in the interval from x sub n to B. Okay, therefore set A be equal to x sub n and go back to step 2. Now, if it happens that f of A is f of A times f of x sub n is equal to 0, then R is equal to x sub n. Okay, stop iteration. Okay, then whatever your x sub n is, your approximate is exactly the root r. So you have to terminate what you're doing, terminate the iteration already. Okay, so let's apply this formula to answer the same example that we had last time. So example, solve this using bisection method. The function f of x equals x cubed minus x squared minus 2x plus 1. This time, the stopping criterion would be, instead of using the absolute error, we'll have the relative error. it should be less than or equal to 0.5. 0.5%. Okay, remember the formula for the relative error. That's equal to x of n minus x of n minus 1 over x of n. This is absolute value times 100%. Okay, where x of n is the current estimate, x of n minus 1 is the previous estimate. Okay, we already know that this has three roots. This function has three zeros. One of them is negative and the other two positive. Okay. Now, we'll solve for the smaller root, for the smaller positive root. Positive root. Okay. May calculator na lahat kasi medyo mahaba ang computation nito. Hatiin ko kayo sa tatlo pagka-compute, no? Yung first, sige, si from Abarquez hanggang kay Kalubakib na lang. So, you will compute for x of n, ha? So, pakita ko lang muna yung table. The table contain, of course, n, and then a and b, and then for x of n. And then we have to look at the product of f of a times f of x of n. And then we have to compute for the relative error also. So from hanggang kay Kalubakib, you compute for x of n, ha? And then from Castillo hanggang kay Legazpi, ayun, wala. Hanggang kay Lim, okay? Castillo to Lim, you compute for you have to look at the sign of the product of f of a and f of x of n, okay? And then the remaining students, ito, Encarnacion, Lozada hanggang dun sa dulo, you will compute for the relative error. Now, in your calculators, you will enter this. Sa calcu, space dito. Ito na lang sa baba. So, in your calculators, for x of n, okay, this is what you write. So, x equals, use a and b na lang because we are also using a and b here, but capital letters in your calculator. So, just a plus b over 2. Yan lang. Type nyo yan, and then later on, use sheet solve. And then you'll enter the values for a and b that we'll have here. Okay? A and b. And then for those who will compute for the sign of this, sign lang ang concern natin dyan, ha, not the value anymore. That's f of a times f of x of n, no? You will enter this. So for f of a times f of x of n, you'll enter this. So x equals f of a, so ang f natin is this function. So you have to enter that. But this time using the variable a cubed minus a squared minus 2a plus 1 times, we can use the variable y there, y cubed minus y squared minus 2y plus 1. Later on, the value of a here would be whatever a is in our computations, and the value of y will be whatever x sub n is here. Okay? And then, of course, for those who will compute for the relative error, write this in your calculator. X equals, ano gusto nyo gamiting variables? A, B na lang din. A minus B over A times 100. Yung A ninyo dito ay yung current estimate. Okay, and then B is the previous estimate. Okay? Ilike mo sa calculator. All right. So we already know that the smaller positive root for this particular function or for this particular equation when when f is equated to 0 is in between 0 and 1. Kasi what we got is actually I gave you the first positive root ang binigay ko last time na initial approximate value is 0.5. So 0.5 is in between 0 and 1. So we'll choose 0 and 1 for the first iteration, 0 for A, 1 for B. Because this is a bracketing method, A should always be less than B here, okay? A is always less than B. Okay. Why? Because why 0 and 1? Look at this. What's the value of f of 0? F of 0 is 0 cubed minus 0 squared minus 2 times 0 plus 1. This is positive 1, obviously. What is the value of f of 1? It's 1 cubed minus 1 squared minus 2 times 1 plus 1. Okay, negative 2 ito plus 1, you get a negative 1. So it means to say that f of 0 times f of 1 is less than 0, which is a negative number. So in between 0 and 1, it means to say that in between 0 and 1, there is at least one root, and that is actually the smaller positive root in this for this particular function. Huh? Now, obviously, x sub n using the midpoint formula is 0.5. Huh? 0.5. No need for a calculator. Now, can you tell me the sign of f of a times f of x sub n? Those who will compute for the sign. So just substitute 0 for a, and then for y, substitute 0.5. What will be the sign of the product? It's the sign of the product. Negative. Okay. That is correct. Negative. Alright, wala pa tayong relative error kasi wala pa tayong previous approximation, no? If this is negative, look at this, step 3. If this product is negative, then R is in the interval from A to x sub n. So set B equal to x sub n. So papalitan natin yung B ng x sub n. So in the second iteration, A is still 0, B is 0.5. Okay. Now, in between 0 and right in the middle of 0 and 0.5, it's 0.25, no? Without actually using our calculator. Now, what is the value of f of a times f of x sub n? If a is 0 and x sub n is 0.25, what is the sign, of the product? Okay, it's positive. So, it's positive here. Now, paki-compute na yung error. This time, ang A mo ay 0.25, this is your current estimate, and then your B, which is your previous estimate, is 0.5. Okay, now if this is positive, now instead of changing B, we change A. Okay, we substitute 0.25 to A this time in the third iteration. 0.25 and this is 0.5. Okay, so pag negative, ang papalitan si B. Pag positive, ang papalitan si A. We hope that's clear. What is the relative error in the second iteration? What's the relative error? Yung mga nasa huli kanina, pinasabi ko sila mag-compute ng relative error. The relative error? 0.25 to 0.5 to 0.25. Saan yung magko-compute ng mga errors? Nauuna pa yung sign eh. Oh. Error muna for the second iteration. Ito yung pina-enter ko. A is the current estimate, B is the previous estimate. So A is 0.25, B is 0.5. Lazada 2 billion yi. 0.17. Ang baba naman yan. Percent pati to, iho. Ito yung formula natin. X equals A minus B over A. Positive lang ang kunin ninyo. Wag na yung negative side. $100 is correct. No? Should be 100. So this should be 100%. Yes. Okay. All right. So what is x sub n in the third iteration? If A is 0.25 and B is 0.5. So we'll compute for x sub n in our calculators. 0.375 is correct. 0.375. Now sign of f of A times f of x sub n. Use 0.25 and 0.375 for A and Y in your calculator. Positive. And then the error, please. While we go to the fourth iteration. So kung positive to ang papalitan si A, diba? This should be 0.375 and this is still 0.5. What is the error here? Current estimate is 0.375 and then previous estimate is 0.25. 33.33 is correct. 33.33%. Okay, we will stop iteration if the error is less than or equal to 0.5%. Medyo mahaba pa. What is x sub n here in the fourth iteration where A is 0.375 and B is 0.5? 0.4375 and then the sign of f of A times f of x sub n. A is 0.375, x sub n is 0.4375. Sign. Sign of this product. So it's still positive, yes, positive. And then the error, please. So this is the current estimate, 0.4375. Previous estimate is 0.375. Okay? In the fifth one, so since positive pa din ito, we will change A. Okay, to x sub n. So this is now 0.4375 and this B is still 0.5. What is the error? Relative error in the fourth iteration. 14.29% is correct. 14.29%. Okay. Now what is x sub 5? In the fifth iteration, what is the approximate value? 0.468, ano ba? 4688 yan, no? In 4 decimal places. 4688. 0.4688. And then what is the sign of this product? .4375 and then 0.4688 for x sub n. What's the sign of the product of f of A and f of x sub n? Negative is correct. So if this is negative, we change B. Right? Kindly compute for the relative error in the fifth iteration. So this is 0.4375 still, and then B would be 0.4688. What is the relative error in the fifth iteration? 6.6. 6.68. Wait, I'll answer your question. 6.68%. Kung positive or negative, yung the product of f of A and f of x sub n. What is f of A? It's the value of the function at x equals A. So you substitute, for example, in the first iteration, you substitute 0 for A. And then what's the value of f of x sub n? This is x sub n, no? That's the value of the function f at x equals 0.5. So, substitute mo naman yung 0.5 dito. So, this is actually f of a. Pag sinubstitute mo yung 0 dito, times f of x sub n, pag sinubstitute mo yung value ng function, pag sinubstitute mo yung 0.5 dito. Now, whatever that value is, ang concern lang natin is the sign, not the exact value anymore. Yun lang. In your calculator, you just have to enter that. So, minultiply natin yung f of a times f of x sub n. Okay? Saan na tayo? Alright, we're now in x sub 6. I think kulang yung ano natin dito. So, the value of x sub 6. X sub 6 is 0.453. Iba-iba yung ano nyo, round off nyo. Dapat pares kayo ng round off. Pagdating nyo sa quiz o sa exam, baka mamaya magkakaiba kayo ng ano. Pakitingnan maigi yung kasunod nung na number nitong 1. Ayan. So, 4532, diba? Kasi pagka mali mula sa umpisa, no? 4532. Pagka dito pa lang sa umpisa, mali na yung rounding off nyo. Pagdating doon, masyado nag-overround na kayo, no? Sobra-sobra na. Lalayo na ng lalayo yung final answer nyo. Okay, what's the sign of f of a times f of x sub n in the 6th iteration? Positive. For a is 0.4375 and then x sub n is 0.4532. Okay, negative. Negative, no? Not positive. It should be negative. Okay? Now, kindly compute for the error between these two approximate values. And then we go to the 7th iteration. Since negative ito, ang papalitan natin ay si B. No? So, A remains to be 0.4375 and now B is 0.4532. 453. Okay, what is the the relative error in the 6th iteration? $3.46. I have 3.44. Pakitingnan nga maigi. Percentage. Percentage relative error is this. So this is the current estimate. This is the previous one over the current estimate. Okay? So itong 0.4532 minus the previous one divided by 0.4532 ulit. Ganun siya. Tapos times 100. So in your calculator, you may use this. Okay, where A is the current estimate, B is the previous estimate. A and Y, kahit anong variable lang gamitin mo, iho, pwede. Basta alam mo na yung A ay yung current mo at yung Y ay yung previous estimate mo. Okay? So 3.40. Let me check lang na para tayo. 0.4532. 3.44 talaga eh. Bakit 3.46 pa? I have 3.44 in my calculator. 3.44. Okay, 3.44. All right, in the 7th iteration, what is x sub n? .4454. What about the sign of the product of these two numbers? Negative pa din. All right, negative. Negative, so we change B. Kindly compute for the relative error. We're almost there. We change B 0.4375 and then B will now be 0.4454. What is this equal to? Relative error in the seventh iteration is 1.75. Okay, we are almost there. What is x sub 8? 0.4415. And then what is the sign of f of 8 times f of x sub n? Sign dito. F of A, f of 0.4375. F of x sub n, f of 4415. Positive is correct. If this is positive, we change the value of A to x sub n. So this will now be 0.4415, and this is still 0.4454. Okay, kindly check the relative error in the 8th iteration. 0.88% is correct. Or maybe it's just one last iteration na lang, ano, before we get to the requirement here. Less than or equal to 0.5%. What is x sub 9? 0.4435. Check first the relative error. Because if we have already satisfied the stopping criterion, then this is not important anymore. Relative error is 0.40, 43 ba? 45. Is it 0.43 or 0.45? Kindly check the relative error 0.43 or 0.45. Current estimate is 0.4435 and then previous one is 0.4415. It's 0.45, not 43. Bakit nagkakamali ng ano? Ang divisor nyo is the current estimate ha, not the previous estimate. This is 0.45, which is less than 0.5%. Okay, so this is our approximation for the root cause. Okay? Oh, any questions? Or bisection method? Do you still want us to solve for this larger positive root, or this example is enough for you? Solve pa natin yung larger positive root, or enough na to for this section? We are only discussing two bracketing methods, no? So ito na yung una. Tapos I have another. Again, do you want me to solve for the larger positive root, or you think this example is enough for you to follow the concept and the process? Sige po. Sige po. Sige, next topic. Or sige, compute natin yung another positive root. Solve pa po. Okay. Solve pa po. For the larger positive root, don't erase your formulas in your calculators. We will be doing the same thing, ha. But we will be looking for the larger positive root. Positive root. Okay. In our first lecture, the initial approximation for the larger positive root is 1.5, no? So second positive root, 1.5. So it means to say that the larger positive root is in between 1 and 2. In between 1 and 2. So Our A here would be 1 and then B is 2. But let's check. What is f of 1 equal to? F of 1, we already know that. It's equal to negative 1 a while ago, right? What is f of 2? F of 2 is 2 cubed minus 2 squared. Okay, minus 2 times 2 plus 1. Dapat positive ang labas nito. So this is 8 minus 4 plus 1. So it's equal to positive, right? So it means to say that f of 1 times f of 2 is less than 0. Therefore, there is at least one root in between 1 and 2. So we can use 1 for A and then 2 for B for the first iteration. And then solve for x of n. Find the sign of f of A times f of x of n. And then compute for the relative error. Of course, x of n here in the first iteration is 1.5. What is the sign of f of A times f of x of n? Using the same formulas in your calculator. Do not erase because we are using the same function anyway. What's the sign? Ma'am, given po ulit yung mga roots. Yun nga yung sinosolve natin yung roots. Given yung, yes, for this, yung sa quiz natin, of course, for the sake of yung uniformity and consistency ng solutions natin, I will be giving you the initial approximates. Okay? Yes. X sub n, syempre ikaw ang magsosolve nun. Yun na nga yung hinahanap natin, X sub n. X sub n, ang hinahanap natin. Ito lang ang ibibigay ko, yung initial values. Or yung endpoints ng mo bracket or ng interval, no? Okay, what's the sign here in your calculator? Negative? Tingnan nyo ha. Kasi, tingnan mo sa GeoGebra, tingnan natin yung para may idea kayo kung mali yung calculations ninyo. Yung sa bahay nyo naman ginagawa, x cubed minus x squared minus 2x plus 1. Ito yung dapat maging sagot natin. Ito yung second positive root niya. 1.8019. 1.8019. So, dapat, itong number na to dapat laging nasa loob nung bracket natin, no? Nung interval natin from A to B. Saan tayo? From A to B. Pag negative ito, ano papalitan natin? Papalitan natin pag negative, A or B? We change B, di ba? Pag negative, we change B. The second iteration, this will be 1 and this will be 1.5. You think 1.8019 is in between 1 and 1.5? Change B, tama yon. Kung negative, we change B. Kung papalitan natin yung B ng 1.5, is 1.8 in between 1 and 1.5. No, di ba? So, ibig sabihin, pag dito pa lang sa second iteration, may mali ka na. Ibig sabihin ito, there's something wrong with this. Paki-check, bakit ganun? Di ba naka-enter na to sa calculator ninyo? So, A is 1, and then Y is 1.5. Dapat positive ang lalabas para ang papalitan natin A. Diba? This should be positive. So that we change A to x sub n. This is from 1.5, and then we retain the value of B, 2. So 1.8 is still in between these two, right? Kindly check. If it's really negative, then there's something wrong with what we are doing. Negative pa din, yung product. Negative. Let me check. Kahit sa unang table, bakit? Teka lang. Let me check ha. Bakit ganyan nilalabas ng calculator? Positive sa akin eh. Bakit sa inyo negative? Positive 0.8752 eh. Ma'am, sa F1 times F2 po, di po ba dapat greater than 0? Saan iho? Here? F1 times F2? Di ba F1? F1 times F2 is actually, what is F of 1? Negative 1. What is F of 2? 1. So, that is negative 1, less than 0, di ba? Greater than 1 ba? Greater than 0 by negative 1? Okay. Yung sa calculator nyo, ano ba yung calculator nyo? Ba't mali ang binibigay? Pare-pares kayo negative. Tama ba yung pagka-enter nyo ng function? Kindly check. Ito dapat, exactly ito. Yan. Tapos shift solve, pagpasok ng, dapat 1 yung A, and then the value of Y should be 1.5. So, 0.875 yan, positive. Okay na. Okay, ano ginagawa nyo pang okay, positive, no? Alright, so positive. Wala pa tayong relative error. Now, for x sub 2, here, this is 1.75. Madaling malaman without calculator, no? Gitna lang ng 1.5 and 2, it's 1.75. Now, look at the sign of f of a times f of x of n. Remember, 1.8 should always be in the interval from a to b. Larger, dalawa kasi yung positive roots. Ito yung smaller, ito yung larger. Diba sabi ko kanina, we have already used this example last time. We have 2 positive roots and 1 negative root. Okay, so para lang malaman nyo kung ano yung sinusolve natin. Smaller and then the other one is larger. Okay. So kanina sa graph, ito yung sinusolve natin. Mas maliit na positive root. Ito ngayon yung sinusolve ko. The larger positive root. Okay? Gets 0.5 po yung gamit. Saan? 0.5 yung gamit saan? bracketing method ito, so dapat interval ang gamit. So sa smaller positive root from 0 to 1, pag tinignan mo, yung positive root, smaller positive root is in between 0 and 1. And then I am using 1 and 2 now. The interval from 1 to 2 for solving the larger positive root. So what's the sign? Positive, no? This is positive. So we change B pa din. We change A pa din. Sorry, that's positive. So we change A to 1.75 and then B remains to be 2. Now what is X sub N? Kindly compute for the relative error in the second iteration. Okay, the current estimate is 1.75 and then the previous estimate is 1.5. What's the relative error? Relative error for the second iteration. $1.875 here. What is the relative error in the second iteration? Tapos wag kayong tamarin pumindot sa calculator kasi kung ako ibibigay ko na lang sa inyo yung values, gusto niyo isulat ko na lang. Paano niyo malalaman kung paano kinompute? Pag sinulat ko ganyan, may kopya na ako niyan kasi sinolve ko na yan. Pag sinulat ko negative to, paano mo malalaman? Diba? Hindi nyo maiintindihan. Sige, isusulat ko. 4, tapos 1.75 dito, dito 1.875, dito 1.8125, dito negative. Natutunan mo? Hindi, di ba? That's why I'm asking you to solve. Kaya huwag kayong tamaring pindutin kasi yun yung lang yung gagawin nyo, pinipindutin nyo. Sinolve ko din yan. Ako lang mag-isa nag-solve din yan. Dito, tulong-tulong tayo. Okay, paano kunin yung sa error? Relative error is this, di ba? Sabi ko, you write this in your calculator, exactly this, because this is our formula for relative error. So this is the current estimate minus the previous estimate over the current estimate times 100. Now, I don't want the answer to be negative, so laging may absolute value ito, no? Sa calculator mo, enter this exactly and then shift solve. Dun sa A mo, ang i-enter mo yung current estimate. So, current estimate mo dito for the third iteration is 1.875. And then B is the previous estimate. The previous estimate for the third iteration is 1.75. Okay, hit shift solve, tapos enter, hit yung equal sign twice, lalabas niya yung relative error. Palaki naman yung error na yung 1.875. Dapat paliit, di ba? Nasa 14.29 na tayo. 6.67 is correct. 6.67 is correct. All right, now let's go to the next one. Since this is negative, when you get the product of f of a and f of x sub n, so a is 1.75, x sub n is 1.875, this is negative, no? So if it's negative, then we change the value of b. Sinulat ko na kanina, di ba? So a will remain to be 1.75, 1.875 na si b. Now get x sub n when a is 1.75 and b is 1.875. $1.81 for decimal places 8125. Okay, 1.8125. Now, as I mentioned a while ago, negative na to, no? Negative when you try to multiply the values of f of a and f of x of n. You'll get a negative value. And then the relative error for the fourth iteration, this is the current estimate, 1.8125. The previous estimate is 1.875. 3.45% is correct. 3.45%. Okay? So for the fifth iteration, since we have a negative sign in this column, we change the value of B. So 1.75 pa rin si A. B is now 1.8125. Okay, what is X sub N? Yes, 1.7813 is correct. 1.7813. And then what's the sign of this product? Yes, it's positive. So we have to change the value of A to X sub N. In the sixth iteration, this is now 1.7813 and B remains to be 1.8125. What is the relative error in the fifth iteration? 1.75 is correct. Right? What about X sub N in the sixth iteration? So what is X sub 6? X sub 6 is 1.7969 is correct. 7969. What about the sign of f of A times f of X sub N? Okay. Positive is correct. Kindly compute for the error in the sixth iteration. So in the seventh iteration, we change the value of A. 1.7969. This is still 1.8125. The value of X sub 7 after we get the value of the relative error in the sixth iteration. 0.87% is correct. Okay, we're almost there. Maybe this is the last iteration, 87%. What is X sub N in X sub 7? Ito na tayo, X sub 7. 1.8047, yes. 1.8047. Kindly check this first kasi 0.87 is very close to 0.5%. Okay. Hindi mo na importante to kung nasatisfy na natin yung ano. Kindly check the relative error first. 0.43. Okay, so we have satisfied the stopping criterion. 0.43% is less than 0.5%, our stopping criterion. So, ito na yung sagot natin. 0.8047. In the graph, if you try to look at the graph, it's at 0.8019. Medyo malayo, no? Kasi if you'll notice, yung relative error natin medyo malaki-laki pa eh. No? Medyo malaki-laki pa. Because bisection method is really very slow to converge to the root of the equation. Medyo mabagal siya if you notice. No, we have 9 iterations here, but the relative error is still hindi pa ganun kaliit. No? Unlike nung ginawa natin last time, the absolute error is very, very small. Okay? Pag ginawa nating mas maliit pa to, mas hahaba pa yung iteration natin. If you know how to use yung mga formula sa Excel, actually yung gagawin natin sa mamaya MATLAB, so we'll be using bisection method, or without MATLAB, you can actually use Excel, no? If you know how to use yung if function sa Excel, if function lang to eh. Kasi you have to change either A or B, diba? Depending on the sign of this. So it's just by using if function, i-drag mo lang to, dire-diretso yan. Makukuha mo agad yung sagot mo dito. Okay? Questions? You have questions about bisection method? None. Okay. Paano pag trigo yung function? Okay, sige. Paano pag trigo yung function? Ano magiging difference pag try ko yung function? It's the same procedure. Okay? Same procedure, walang pagkakaiba. Ang magbabago lang yung i-enter mo sa calculator mo. Whatever your function is, kung sin x man yan, magbabago lang ito. Magiging sin A times sin Y. Ganun lang. Diba? Ito lang yung magbabago sa calculator mo. Pero ito, parehas pa din yan sa calculator mo. Ito, parehas pa rin sa calculator. Ay, dito lang magkakaiba. Ito kasi kung ano yung given function mo. Tingnan mo, sinundan niya yun. Kaya lang, using a different variable. Ito, x cubed minus x squared minus 2x plus 1. Ginawa ko lang A dito, ginawa ko lang. Okay, so for whatever your function is, it's the same procedure. Okay, tapos depende rin sa stopping criteria. Pagka trigo function, lagi naka-radians. Okay? Lagi naka-radians ha. Make sure naka-radians pag nagsisolve kayo ng merong trigo functions. Okay? Alright. Next, we'll go to the last root finding method. It's called regular fallacy. We'll actually be using the same procedure but different formula. Or in English, this is false position. False position. This is what we call the linear interpolation. Linear interpolation method. Because what we do here is say you have a function. Okay. So you have a function f. All right. So this is the root of the function, no? Or say for example, this is your the interval from a to b. So this is x equals a. This is x equals b. Right. This is f of a. And then since this is x equals b, this is f of b. Okay. What we do is connect these 2 points. Connect these 2 points. So this point at a f of a and this other point at b f of b. Connect the 2 points together. Okay. And then this will be x sub n. This will be x sub n. This will be your approximate or estimate. Okay. So false position because this is actually just the root of the line connecting the 2 points on the curve f of x. Diba? The true root is actually where the curve f or the graph of f crosses the x-axis. But this is just the root of the line. So parang inaano mo lang, parang inapproximate mo lang roughly the curve f, the graph of f is approximately that line, no? So it's false position. That's why it's called false position. Okay, but then this is also a bracketing method, so you always have this bracket or this interval. Right? Now from that two interval, let's just derive the formula. From the two intervals, we have created two right triangles here. One is this right triangle, which is smaller than the other, and then the other right triangle is this. Those two right triangles are actually similar triangles. So if the two are similar triangles, then we can use ratio and proportion. No? So ratio and proportion using similar triangles. Using similar triangles. Okay, the height of this particular triangle, the smaller one, is f of a. Or let's say it's negative f of a because it's below the x-axis. But then we are actually pertaining to length, no? So this is not important anymore. And then the length of the base of this smaller triangle is actually x sub n minus a. This is a, this is x sub n. So it's x sub n minus a. And then for the larger triangle, the altitude is f of b. And the length is b minus x sub n. Or, since we remove the negative sign of this, the length of the base of the bigger triangle is x sub n minus b. Okay, so from here, you solve for x sub n. That's how you derive the formula. And x sub n would be equal to, from there, would be b minus f of b times a minus b, over, dito lang lahat galing yan ha, f of a minus f of b. Okay, this will be our formula. Yan ang formula natin gagawin. Okay, use the procedure. For bisection method. Okay, but use the formula. For regular falsi in step 2. Okay, kasi di ba remember in step 2, use the formula x sub n, this one. This is the formula for bisection method. This is the only thing that we will change. Okay, but step 3 will remain the same. Step 1 is still the same in regular falsi. We'll just change the formula in step 2. Alright, tingnan natin kung sino mas mabilis mag-converge. So root, given the same example, given the same relative error, but this time by using another formula. Okay, so n pa rin, you'll have n a, b, x sub n, and then you still have to look at the sign of f of a times f of x sub n, and then you have to compute for the relative error. So same example, x cubed minus, write it as f of x cubed minus x squared minus 2x plus 1. And then you have to satisfy the stopping criterion, which is the relative error should be less than or equal to 0.5%. Let's see who's faster to converge. Now, in your calculator, it's the same for the relative error. Relative error pareho. Now, for f of x sub a and f of x sub n, parehas pa din, no? It's still the same thing because we are to satisfy the same product, no? The same sign, the same condition pa rin naman di ba? Now, for x sub n, we now have a different formula for x sub n. So, sa calculator nyo, in your calculator, magsosolve ha. Same function but different formula for x sub n. So for x sub n, it's x equals b. So sa calculator, type b minus, fraction nyo na ha, fraction nyo na. F of b is b cubed minus b squared minus 2b plus 1. And then a minus b. Okay, in the denominator, f of a is a cubed minus a squared minus 2a plus 1. Plus 1 minus f of b. Yun ulit, b cubed minus b squared minus 2b plus 1. I'll type this, exactly this ha, in your calculator and then shift solve. We'll start with, in the first iteration, a equals 0 and b equals 1 pa din for the smaller positive root. Kindly enter this in your calculator first. So this is for the smaller positive root. Ma'am, pwede po kayo magbigay ng hindi f of x yung function. Ano yung hindi f of x yung function? O, di papalitan ko to ng g of x, gano'n. Papalitan ko ng g, o ayaw mo ng f of x? Ano ibig mo sabihin, iho? Hindi function yan, iho. That's just an equation. Hindi yan function. Equation yan. Equation. So, kasi, iho, ito yan ha. Kasi we are, during the first conference, ang sinusolve natin, kasi root finding ito, di ba? Ganito kasi yan, iho. Okay, ang function natin, ganito, no? Ganito yung itsura. Ano ba yun? Ito na lang, sa graph, para mas madali mo makita. Okay, ito yung function natin. No? Hinahanap natin yung roots ng equation or yung zeros ng function ang tawag natin. Kasi, it's either you use the term roots or zeros. Ang tama kasi, zeros of the function, of a function na lang. Sorry. Of a function or roots of an equation. Ito, they mean the same thing here, ha? Kasi yung zeros ng function, kaya mo sinabing zeros ng function. Kasi, hinahanap mo yung mga values ni x kung saan zero yung value ng function. Tingnan mo yung mga, look at this. Okay? This is the root, di ba sabi niya? Kasi this is the root of the equation when the value of y is 0. That's why we call this zeros or zero of a function. Ganun din dito. Root siya, di ba? 0 yung y, may value yung x. That's why this is called a zero of the same function. O ganun din dito. Diba? So, yung gusto mong sinasabi mong x equals ito, when we equate, tingnan mo itong una kong sinulat dito. Sa first meeting natin. Write f of x equals 0. So, if I write f of x, if I equate f of x to 0, then that function would be x cubed minus x squared minus 2x plus 1. Pag in-equate ko to sa 0, anong kukunin natin? Kinukuha natin yung 0 ng function which is the root of this equation. Diba? So, kung ayaw mong ilagay ko yung f of x doon at gusto mo isulat ko yung function or yung equation in this way, you will not be able to understand that what I am asking here in this column is the value of the function at x equals a times the value of the function at x equals x sub n. Okay? So without that notation, then it's not right to write f of a times f of x sub n in the fifth column. Nakuha mo, Iho? That's just for notation lang para you know that what I am talking about here in the fifth column. You know that I'm talking about the product of the values of the function at x equals a and at x equals x sub n. But you're actually finding the root or the zeros of the function, the root of the equation, and you can only do that by equating f to 0. So, mawawala yung f of x na ayaw mo dun. Hindi ko po kasi ma-solve sa MATLAB yung ibang problems mo, kaya ko po natanong. Alin doon? Yung falsi method po. Wala pang regular falsi doon. Fixed point. Fixed point? Sige, mamaya, we'll talk about that. So, yung x equals x squared mo na yan, x squared plus 1, yan. X equals x squared plus 1 na gusto mo. Kung ta-transpose ko yan doon, you'll have x squared minus x plus 1 equals 0, di ba? Okay, you can find the root of this function or of this equation or the 0 of the function f of x equals x squared minus x plus 1. Okay, pag sinabi mong find the root of this equation or find the 0 of this function, I am pertaining to the same thing. We are finding the root of this equation. Okay? So, walang difference yun. Notation lang natin yun para maintindihan nyo kung ano ito. Right? So, what is x sub n here? Na-enter nyo na to sa calculator nyo. What is x sub n in the first iteration? 0.5. Ma'am, yung falsi method po, hindi na compute yung f of h at f of b. Hindi na. Itong regular falsi, kukumputin. Regular falsi, kukumputin. Ayan, no? Meron tayong file. So, kung ano yung ginamit dito sa calculator a while ago, ito, yan pa rin yun. Same thing. Kasi sabi ko, use the procedure for bisection method but use the formula for regular falsi instead. So, the sign of f of a times f of x sub n. Sure. Alam mo na yung sagot, di ba? Ang sagot is somewhere here. Di ba? Malapit sa 0.44. 0.44. So, pagka positive ito, change natin A, di ba? 0.5 ito, 1 ito. You think the answer will still be in this interval? Wala na, di ba? Labas na siya agad. Kasi you already have an idea. And kung nagko-quiz man kayo, pwede nyong i-graph sa GeoGebra yun, di ba? Makikita nyo na, ay, wala dun sa interval na yun yung nasa graph. So, there must be something wrong with my calculations. Dapat, in your calculation, dapat negative ang lumabas dito. But kasi I know that it's very close, the answer will be very close to 0.44. So, dapat ito ay 0, dapat ito maging 0.5 so that the root will still be in the interval from 0 to 0.5. Nasusundan niyo yung ganon? No? Negative 1.25 po pala yung input ko sa calcu. Saan yung negative 1.25? Ano yung negative 1.25? Saan galing yun? O pala ba yung B po yung na-input? Mali yung input mo. Okay. So, it should be 0.5, no? So, negative. Alright. So, what is x sub 2 here? If A is 0 and B is 0.5. .4444 is correct. So malapit ka na agad, di ba? Mas mabilis siya mag-converge. And then this is positive if you check. Check. It should be positive. And then the relative error would be 12.51. Medyo mas mababa na siya agad sa second iteration pa lang. Now, in the third one, so papalitan ko ngayon ay si A. This should be 0.4444 and this will remain 0.5. And then x sub 3 would now be equal to 0.4450 na agad. 0.4450. Okay, this is very small na yung ating relative error, which is less than 0.5%. So, mas maliit yung relative error. This is 0.13 lang, ano, as compared to this, which is 0.45. So, ang sagot dito, 0.4435, no? Dito ay 0.4450. Let us look at the graph. Dito ay 0.4450. So, equal na siya in 4 decimal places dun sa graphical method, ano. So, in just 3 iterations, kuha na agad natin yung sagot. Mas maliit pa yung error, relative error. So, mabagal talaga mag-ano yung bisection method, mag-converge. Right? Okay, wag niyo burahin yung formula sa calculator. Let's solve for the other positive root. For the larger one, larger positive root. Okay, and malapit na tayo matapos. Last na to. Huwag na kayo mainip. Mag-calculator na kayo para mabilis tayo makapagpahinga. Relative error. So, we'll use the same A and B. So, A and B natin, last computation natin is 1 and 2, no? For the larger positive root. So, in the first iteration, A is 1, B is 5. And still, what this would be at what 5? 2. This is still 1.5. Okay? Here, you can check. You can solve for X. Okay? When A is 1 and B is 2. Here. Ang lalabas pa rin is 1.5. Okay, so what will be the sign of f of A times f of x sub n if A is 1 and then x sub n is 1.5? Okay, positive. Positive ito. So we will be changing the value of A to 1.5 in the second iteration. B is 2. We know that it is very close. The answer should be very close to 1.8, no? So you always have to check your interval. What is x sub 2? Using this formula, this x sub 2, in 4 decimal places. Okay, tatlong 3. 1.7333. What about the sign? And then compute for the relative error also. Okay. Positive. I think this is 13.46 and not 45, 46%. Okay, so positive ito, we have to change the value of A again to 1.7333. And B will remain 2 in the third iteration. What is x sub 3? $1.7889 is correct. This is still positive, I believe. Positive, kindly check. And kindly check if this is really 3.11. Positive, and then 3.11. Okay, thank you. All right, so positive pa rin. We'll change the value of A in the fourth iteration. This will now be 1.7889. This is still 2. And what is x sub 4? Yep, correct. 1.7996. 7996. What about this sign? It's positive. And then the error, I think it's close to 0.5, 0.6, 0.59 in two decimal places. Now let's just be consistent. Two decimal places. Okay, in the fifth iteration, we have not yet satisfied the criterion. No, change A to 1.7996, and this will remain 2. And then x sub 5 is, what is x sub 5 equal to? 1.8050. So I think we already have satisfied. Okay, this is 0.11, very, very small. 0.11%. Okay? Tama na dito in 4 decimal places. So, not yet. 0.8019 ito pala. This is 0.8015. Okay? So, in 3 decimal places, tatama siya because of this relative error. Okay? That is regular fallacy. And that is actually all for root finding methods. No? You have learned three root finding methods, 3 of which are open methods. The first one is yung fixed point iteration. The second one is Newton-Raphson method, which is the fastest to converge, especially for this particular example that we had, the polynomial function. So Newton-Raphson method is actually the fastest to converge among the 5, as long as you pick your current or your initial approximate correctly. Okay? For a good choice of initial approximate, this is really very, very fast to converge. Okay, and then the secant method. And then 2 for the bracketing method. One is bisection, the other one is regular fallacy. All right? Do you have any questions? Do you have any questions? Five po lahat ng method. So, 5 siya. Tatlong open. Yes, I will share this to you later after our class. Okay. Let's go to, hindi ko pa napapublish yung yung para sa second, simulation. Publish ko na ba? Wala pa, hindi pa nakapublish. Itong bisection method, papublish ko later. This should be submitted next Thursday ulit, no? Hindi pa lahat nakakapag-submit ng laboratory activity number 1. Kasi mamaya pa lang yung June na eh. Sige, papublish ko na ito para maano. Itong quiz, ready na din to. Ipapublish ko na lang. Hindi ito yung quiz. Ipapublish ko na lang mamaya yung dalawang quiz. Yung isang quiz at saka yung isang homework. Okay. Yung laboratory, check ko na yata. May section method. O para dun sa tapos na magpasa ng activity 1, pwede nang i-open to. Activity number 2. Ganun pa rin to, no? Kaya lang ito, purong bisection method lang. Walang regular fallacy dito. In your MATLAB, so ito, copy nyo lang to. Doon ulit, gagawa kayo ng script ulit para magkaroon ng function na bisection. Copy this, all of this. I think wala naman tong error, no? All of this. Copy dito sa may script page, no? Script window. Tapos, save it as bisection. Save it as bisection method.m. Ayan, no? Meron na ako, na-save ko na siya. Copy nyo ulit dito, save bisection method.m. Tapos, after that, so meron ka ng function na bisection, no? Bisection method na function. Tapos, ito, may example number 1, approximate the root of the polynomial in the interval 0.1 to 0.5, no? So, ito yung sinasabing low. Ito yung low doon sa yung isang endpoint, yung mas maliit na endpoint ng inyong interval, no? Yun yung low dito sa function mo. And then yung high would be yung mas malaking endpoint, no? That would be high. Yung tolerance is actually the yung stopping criterion error nyo, no? So, approximate error, that's it. And then the function here, okay, yung function mo dito, baka ito yung sinasabi ng isa kanina na, di ba f of x is written is equal to 5x to the fourth minus 2.0, yan, etc. So, just remove f of x. So, ito lang ang kokopyahin mong function dito. So, once you already have this script saved in your MATLAB, copy nyo din to. I think pwede i-copy to. Tapos, paste it here. Enter. Ayun. Ayan. Root at sinasabihin niya agad. 0.2. So, ito pinapakita niya yung low, high. Ayan. Okay. Ayan. Ito yung sagot. Root. So, ganun lang siya. Or, kunin mo yung output na din-display ng command, sa command window, and then do the same thing here, but for a different function. Okay? And then activity na. Oh, so do the same thing. You just have to change this function to what is given here. What is given here, and you have to change the endpoints of the interval there, sa low at saka sa high. And then you have to change the tolerance if this is different from what is given here in the example. So, ganun lang. And then you can solve. You can have the output already. Oo, laging may screenshot para sigurado akong ginawa nyo talaga. At hindi pare-parehas, no? Na nag-copy-paste lang sa iisang kaklase. Okay? Pang-run para ma-solve ibang problems and applications. Oo. Yun lang siya. Walang ibang program dito eh. Wala regular fallacy, wala. Ayan o. Approximate the root of the following using bisection method. O, yun din. Yun din. Iba lang yung tolerance, iba yung function mo. Okay? Iba yung pagkakasulat, ito equation lang. Ito nakasulat as a function. Diba? Ito din, function din ito. Yan, may tolerance din. So, same, walang ibang gagamitin. Pare-parehas lang. Yun at yun din. Okay? Mamaya po ba ilalagay sa X? Yan po ba yung N? Paano po papalitan? Paano papalitan yung function? Like, anong function? Alin dito? To? Paano mo isusulat sa MATLAB? Kasi bakit nag-error? Hindi mo siguro nilalagyan ng ng yung for multiplication, yung asterisk. Di ba, halimbawa 2.5x squared. Dapat yan 2.5 times. May asterisk dapat in between. 2.5 asterisk, tapos x, tapos yung caret 2. Pag wala ka nilagay na asterisk, talaga mag-i-error yun. Pag type po x, error din po. Huh? Bakit dito? Tingnan mo nga maigi. Sa activity 1? Yung mga nasa exercises, patingin exactly kung paano mo tinype. Bakit nag-error? Same code. Same code pa rin yung gagamitin. Okay, Lazada, yun na yun ha, same pa. Baka MATLAB naglolo ko. Siguro nga, yung sa MATLAB mo naglolo. Anong error ba yan? Sa syntax ba? Tingnan mo kung syntax error. Kung hindi, baka meron, hindi ko alam kasi kung saan mo siya ipinapasok no? Hindi ko alam kung saan mo siya din pinapasok ng matrices dito. Oo,